Section 4.3, Areas of Trapezoids. And our essential question for this video is, how can you derive a formula for the area of a trapezoid? So looking back, we had the area of a triangle and the area of a parallelogram. And they're very similar because a parallelogram, the area equaled base times height. A triangle, the area equaled 1/2 times base times height. So the only difference here is you were basically splitting it in half. Now, if you think about it, if I had a parallelogram and I were to split it in half, now I have two triangles. And that's where the half comes from. We derived a formula from a previous formula of a base times height. Now we're going to be working with a trapezoid, and we need to derive the formula for this based off of what we had before. Well, we had a base times height, and we had 1/2 times base times height. So stay tuned to figure out what that is, and if you'd like to follow along with me in the book, I am on page 168, and we're on the 4.3 lesson. Here we go. So 4.3 lesson, our key idea is the area of a trapezoid. So in words, this means the area A of a trapezoid So the area of a trapezoid, I decided to change that up a little bit. Get my point out. The area A of a trapezoid is 1/2 the product of its height h and the sum of its bases b1 and b2. A couple key words here. We've got the word product. We know product means multiplication. And we've got the word sum. We know the word sum means addition. Don't forget that. That's really important. So algebraically, to write this, it would look like this. Area equals, well, let's go back up here. It's 1/2. I'm just reading from right here. 1/2 the product of its height, so h, and the sum of its bases b1 and b2. b1 plus b2. So I'm just going to reread that again. I'm going to erase, oh, I guess I can't. I'm going to reread that again so that you can see where I came from here. So the area A of a trapezoid is 1/2 the product of its height and the sum of its bases b1 plus b2. So let's look at how it would look on my actual trapezoid over here. So my height comes in like this. Showing my height would be h. So that's where the height would be. You'd usually see a number there. You have two bases to a trapezoid. You've got base 1 on the top, base 2 on the bottom. Now when you write the b1 and b2, I'm going to write it a little bit bigger so you can see. You don't write a 1 like this right down the middle. Okay? You actually write the 1 down here like this. And then on base 2, you're not writing a big 2 like this. Okay? It does not look like that. You're actually writing a small 2 right below it. Okay? So now I have base 1 on the top, base 2 is this length here. So base 1, base 2, and here's my height. Okay? Let's look at what this looks like in an actual example. I think it will help you out a lot more when you have an example. So example 1 is finding areas of trapezoids. So if the directions say find the area of each trapezoid and they give you the shape, this is exactly how you'll have it set up. You'll have more A's this time, so pay attention. So in this example, they give us a trapezoid that has a base 1 of 5 feet, a base 2 of 9 feet, and a height of 6 feet. Now, this trapezoid looks a little different than the one we started with, but if you see a right angle sign like that, that's automatically your height. So this actual side of the trapezoid is included in the height. One thing you have to know about a trapezoid is that, you might want to jot this down, but a trapezoid has 2 parallel lines. The other 2 are not parallel. So it's a shape or a polygon that has 2 parallel lines in it. So you start the problem off with your first A. Your first A is writing out the formula. 1/2 times H times B1 plus B2, and those will always be in parentheses because that's what you need to do first. Your second A will actually be filling in the information. So you start off with your 1/2 times your H, so times 6, times your base 1, which is 5, plus your base 2, which is 9. Okay, so everything's filled in. Your next step is to solve the addition problem first. That's in your original parentheses. This is the original parentheses. Okay, so it starts here. So that's what you're solving first. So your next line will look like this. Your next A. We haven't done anything with our 6. 5 plus 9 gives me 14. And then you go on to your next one. So your next A, we still have 1/2. We do 6 times 14, sorry. Okay, so you're going to do out your problem. You should come up with 84. So now I have 1/2 times 84. I'm just following my steps as I go down. And this is going back to what we talked about with the triangles. You could do out 1/2 times 84 over 1 and go straight across and say 1 times 84 is 84, 2 times 1 is 2. Or you could just look at this and say, oh, that's right, 84, I'm just dividing by 2. So you could do it either way. Either way you think about it, it's going to work. So my final A, if I basically just cut 84 in half, you don't have to write what I just did there. I'm just kind of talking as I go. But my answer should be 42 feet squared. And that's my final answer. That's my area for my first trapezoid. In this next example for part B, you have a trapezoid that looks like this. Now, this one puts in what the height is. So our height is 5 meters. So now you're going to write this out just like we did the other one. You're going to start with your first A, and you're going to write out what the actual formula is. Remember, it's 1/2 height times base 1 plus base 2. Our next A, you're going to fill in those blanks. So our height is, get my pointer, the 5 meters times our base 1, which is always the top one, so it's 8.5 meters, plus our base 2, which is our bottom base, happens to be 11.5 meters. And then our next A, we leave our 1/2, we start doing a little bit of solving. The first thing that we solve is in our parentheses our addition. My pointer back. So if you do it out longhand, which you can, and remember when you're doing this, just as a review, when you're adding up numbers, you're lining up decimals. So you put the bigger number on top, line up those decimals. When you multiply, don't line the decimals up. 5 plus 5 is 10. 8 plus 1 plus 1, 10. 1 plus 1 is 2. And then you remember you put your decimal straight down. So my answer, I can get rid of that 0, would be 20. I'm going to erase this because I'm going to need this room in just a second. I just wanted to do that just as a review because we had some multiplication with decimals and a few people got a little bit distracted by that and didn't line them up correctly. Alright, so we leave our height in there. We solved for what our bases equal together, and it was 20. Our next A, we're going to solve our 5 times 20. In shorthand, we can do this by saying 5 times 2 is 10, and then add that 0, so it's 100. And our last A, again, you can do 1/2 times 100 over 1, go straight across, 2 goes into 100 50 times, or you can just say 100 divided by 2 equals 50. So our answer should be 50 meters squared. Remember, this is a either or. You do it this way or you do it that way. It's not you do it both ways. Just remember, when you get to this point, you have a couple choices. For section 4.3, we're going to actually skip example 2 and move right on to example 3. And this is your real life application. I just wanted to mention that before you started panicking that you couldn't find it in the video, but we skipped example 2. It's finding the area of a trapezoid on a grid, and it's not relevant to what we're learning, so we're going to take that out. What I like about this example is that it actually is pretty relevant of how they approximate people per square mile. And so it gives you an idea of, when you hear that, how many people are there per square mile in, say, a different, like a state, or this example uses as a county. So this actually happens. It's kind of nice to see real life stuff come to life, and you actually can see where it comes from. So it says you can use a trapezoid to approximate the shape of Scott County, Virginia. The population is about 23,200. About how many people are there per square mile? So let me get my pointer. So they're talking about this region right here. This region actually looks like a trapezoid, so we can use that information. You know, you can see obviously right here there's a little bit of area that's a little bit out, but we're just approximating. That's what's important here. We want to know how many people are there in this area per square mile. That's what we're talking about with area. So the first thing that you do is we find the area for our trapezoid that they're giving us. I'm going to start off with my first A. We know it's 1/2 height times B1 plus B2, which is our bases. So let's start plugging in some numbers. Our height happens to be right here. Let me use my green, that should show up. So this line here is my height. The arrow pointing to it, and it actually says h equals, so it's 20 miles. So I'm going to add in my 20. My next thing I'm going to do is my base 1. Base 1 is this line here, and it's represented by pointing to an arrow, and it says B1 equals 15 miles. Go orange here. So my base 1, I'm telling you, is 15, plus my base 2, which they're showing you is this line here, and they even say B2 equals 38 miles. Alright, so everything's added in. The next thing I'm going to do is I'm going to do the adding. Back to my orange. So 1/2 times my 20, which is my height, 20 miles. 15 plus 38 should give you 53. And now I can multiply those two. You could do this out, on the side of your paper. 20 times 53. Put you should come up with 1/2, and it would be times 1060. And again, two ways you could do it. You could just do the 1/2 times the 1060, or you could do 1060 divided by 2. Any way you do it, you're basically splitting up, though, not splitting up, I guess I'm used to doing that and picking that up with Avery. Sorry. The splitting up, you're basically splitting that in half. So 1060 divided by 2, or times 1/2, should give you 530 miles squared. Now I'm not finished, because it says about how many people are there per square mile. So if you finish with 530 miles squared, that doesn't make any sense. The thing's asking how many people are there per square mile. So you have a little bit more work to do. The area of Scott County is about 530 square miles. So you divide the population by the area to find the number of people per square mile. Well, we've got 23,200 people. Well, how many square miles are there? Divided by 530 square miles. Now, you have to actually do the workout, but it comes to about 44 people per square mile. And that would be your final answer. Alright, well that's 4.3. It's pretty simple. Areas of trapezoids. Your practice problems for your 4.3 twirl groups are big green, page 170. You have to do numbers 7, 8, 9, 15, 17, and 19. And out of all of those, the only one is number 8, where you cannot check your work in the back of the book. Should be pretty simple. Numbers 15, 17, and 17, they give you they give you a question like, they don't give you the actual picture of the trapezoid. They tell you what the height equals, they tell you what base 1 equals, they tell you what base 2 equals. You should be able to say, well, area equals 1/2 with my height times base 1 plus base 2, and then fill in, let's say that's 1, 2, and 3. You're going to fill in 1, you're going to fill in 2, and you're going to fill in 3 as you go. So just be careful of that one. We didn't actually do an example of that, but it should be pretty easy. And then 19 might be a little tricky, so do your best. Good luck. And then the following slide will, I have a couple on your own problems to go over, not very many, so if you need a little bit of extra practice, follow along. If not, you're done. Okay, I'm going to do the on your own practice problems from page 168, numbers 1 and 2. Again, try the problem out, pause it, fast forward to the answer. If you got it right, then I think you're in good shape. If you got it wrong, stay tuned, see if you can figure out where you've gone wrong. number 2, I have a trapezoid that looks like this, so this one's kind of upside down. Another thing you need to be careful of now, we know with addition we can flip-flop the numbers and it would still get us the same answer, so we are fortunate with base 1 plus base 2, it will give us the same thing. But technically speaking, base 1 would actually be down here, where base 2 would be on the top. And what gives me that is the fact that the height in the right angle they show you is down there. So if this would technically be flipped over like that, and I would have 7.7 inches down here, 2.3 inches up here, and then my height would be inside here. Okay, so just be careful of that. Again, it's still going to give you the same answer regardless of where you put your 7.7 and your 2.3. Alright, so let's start with our first A. We get 1/2 h times b1 plus b2, base 1 plus base 2. Our next one, we're filling in blanks. Our height is 6 inches. Okay. Our base 1 is 2 and 3 tenths, 2.3. And our base 2 is 7 and 7 tenths, or 7.7. Now again, I'm going to show you how to do this. I'm going to erase this so I have some room. I'm going to show you how to line up these decimals so that you guys have a little bit of review. If I'm adding 2.3 plus 7.7, I am lining up my decimals. Because if you don't, you're going to get the wrong answer. So my decimal place goes straight down. 7 plus 3 is 10, carry my 1. 7 plus 2 plus 1 is 10. So I can get rid of this 0. So I have an answer of 10. So A equals 1/2. I haven't done anything with my 6 yet. I've only added my bases together to get a total of 10. Do it again. 1/2. 6 times 10 gives me 60. And here I am dividing 60 by 2 or timesing it by 1/2, either or, getting the same answer of 30, and making sure that you're labeling and putting your 2 up there for being squared. So 30 inches squared, we're talking about area, and that's my final answer.